3, 2, 1, let's go! Hi everybody and welcome to another exciting edition of Boring JavaScript. I'm your host, the Virtuoid, aka Mike Smith, and today we're going to be talking about classes in JavaScript. Yes, that's right, classes.
There are no such thing as classes in JavaScript.
Ooh, okay. Okay, all right. Let's address the elephant in the room, okay? If you're coming from a programming language like C++, C# or Java, you're not going to get the classes you're used to in JavaScript. Why? Those languages are basically OOP type languages. JavaScript is not. It is a functional language. So what a lot of people used to do, myself included, is we would have a certain design of functions that we would create that simulated classes. And a lot of the people who came from those other languages would go, I can't deal with this. This is just wicked weird. So what the JavaScript gods did a long time ago is they said, okay, listen. We're going to create a class definition that makes it look like you're creating a class, but in reality, you're not. All you're doing is just creating a certain type of functional design. And that is why it is called syntactical sugar. Classes are nothing more than syntactical sugar over functions, which means that when you create a class, what you're really doing internally is creating a function with a certain design pattern. You got it? Great. Okay, so now we can cover classes in JavaScript. Let's get started. Now, to use a class in JavaScript, or to create a class in JavaScript, you use the class verb. And it's very simple. You give it the word class, you give it the name of your class, and then you close everything inside the curly Q brackets. Real simple, real quick. Nothing really to it. Now, just kind of an aside here, by convention, although it's not necessary, normally we always capitalize our class names. I just kind of want to tell you that. So that is something that you'll find a lot of JavaScript shops will do. So just kind of a little aside there. But there are two main parts to a class that you need to be aware of. Those are properties and methods. These are the properties. Properties are basically different objects that are attached to each instance of the class. In this particular case, I have 5 properties defined. The head property, the body property, the legs property, the arms property, and the alive property. Which means if I ever had an instance of this particular class, then I could just say the instance of the class dot head, the instance dot body, the instance dot legs, and so on and so forth, and I'll be able to access these properties. All these properties are what we are called public properties. What do we mean by public properties? They are accessible to the outside world. I know what a couple of y'all are saying right now, well, what about private properties and protected properties? Don't worry about that. Technically, you can do it if you really go through some real rigmarole, but I'm not worried about that. For now, just worried about that you can create properties inside your class, and each one of them are public properties. They are all created within a method called Constructor. Now, Constructor is a method, and to define a method, each one gets its own section within the code for the class. Basically, it's the name of the method, any arguments you want to pass to it, and then its own curly Q blocks. Basically defining, if you want to think of it this way, defining just another function within the class of animals. So in this case, all our properties will be created within the constructor method. And the constructor method is always run each and every single time you create an instance of the particular class. Each one of the other methods will be instantiated as if you were calling a function. So if I had an instance created of this particular animal, I would say instance.born and then pass it a parameter, and it should return something or do something or whatever. Now, it's also important to realize that the reserved word this is always refers to the instance of the class that you have created. It doesn't refer to the class structure itself, like in this case. This does not refer to animal, this dot alive right here, or none of these. This doesn't refer to animal. It refers to the instance that you have created. So if you create a first instance and create a second instance, you could use the word this on both of those instances, and it would keep everything separate. And that's really basically it. Properties are created within the constructor, and methods are created within the animal, within the class definition itself. How do we actually use classes? Very, very simple. It uses the new syntax. And if you've ever done functions before where you created your class-like structures in the functions, of course you would always use the word new to create a new instance of an object. So animal here becomes a class object, and so when we say new animal, that creates an instance of the object. So I would expect my animal to contain a class called new animal that contains 5 properties: head, body, legs, arms, and alive, and 2 methods, born and constructor. So what I've done here for my example is I've created a my animal and a my other animal. And to show you that they are actually different, I've then set the public variable or the public property legs in my other animal to equal 4, which would mean that because I've set that public property, my other animal, the legs property, will equal 4, but the legs property of my animal should be equal to 0 because that's what I've set it to. On my animal, I have executed the born method, and this is how you execute methods on a class. And in this case, when I execute the born method, it works generally like a function. So we'll go inside here and say this is alive, this dot alive equals true. That means that my animal's public property of alive will equal to true, while I should expect my other animal's public property of alive to equal to false. Again, why? Because these 2 instances are completely separate from each other. This is one separate instance of animal. This is another separate instance of animal. Want to see how it works? Of course you do. Let's take a quick look. So let's go over to Node, and let's type in node class. And sure enough, that's what happened. I've got 2 instances of animal. Here's my first instance, which happens to be my animal. Here's my other instance, which happens to be my other animal. Now remember, my other animal, we set legs equal to 4. So sure enough, legs is equal to 4, but notice that legs is equal to 0 in the first one. That is because the class definition has the word this in it, which associates it with the instance of the object. Also, when I executed the born method on my animal, that should have set alive to be true. And sure enough, it did. Here's alive is true. And my other one, alive is still false. Again, because they're separate instances. So this is how you would create instances of your particular class. Let's flip back over to our code here real quick. And just to recap, so here's our class definition. And again, it just tells you everything you need to know, the different properties and the different methods. It has a special constructor method, which always gets executed whenever the instance is created, so that when I did new animal here, constructor got executed, which set all of these variables correctly. I can set public properties just by setting the variable, or excuse me, the property to a certain number, and I can execute any of the methods to be able to change whatever I want to. And that's all there is to creating classes. Next, let's take a look at what we mean by extending classes. And the next thing I want to show you about classes is you can extend it. What do we mean by extend? Well, that means taking a base class and adding properties to it without having to change the base class itself. For example, let's think of the animal kingdom. We have animals within the animal kingdom, but we have different types of animals. We may have dogs, and lizards, and I don't know, cats, for example. Each one of those animals, the dogs, the cats, and the lizards, have properties that are all in common. They have heads, they have legs, they have tails. And so we would define an animal class as being a class that defines common attributes for all the different animals. And then we would define individual classes for cat, for dog, or for lizard to define those particular ones that are specific to those particular animals. To do that in classes, you use an extends object. And in fact, if you're familiar with other programming languages, you know all about extends. Well, we have the exact same thing inside JavaScript. We can take a base class and extend it to where a superclass would be able to use the original base class and then add information onto it. So let's take a quick look at that. Here I have my cat class, and it extends animal. So what I've done here is I've got an animal class, and this looks exactly the same things we had before. And I've created an animal class, and I have exported. Now, just kind of a little aside here. If you are within a browser environment or using normal JavaScript, you'll use export default animal. I happen to be using Node here for all of my examples, so I'm having to use the Node syntax here of module.exports. In reality, and hopefully Node will completely change this as the default later on, you would actually use export default. And the same thing if on the class extension itself. Normally you would just use import in your class name, but because I'm in Node, I'm having to use the require statement. So don't get confused by that. The important thing here is I've got a class called animal that this looks like the exact same class we used in our previous demonstration. And now I'm going to create another class called cat, and cat extends animal. And what that means is that cat will then grab all of the properties and all of the methods within animal and use that as part of cat. And then cat can extend upon that. So animal will not have what cat has, but cat will have everything animal has. Let's show you what happens there. Here I've got my constructor, and cat will inherit these 5 properties: head, body, legs, arms, and alive, and add to it one called tail. And that will be something that is exclusively to cat, that no other animal will have, or no animal will have, only cat. Now, of course, if we had dog or lizard, they would have the same thing. But cat, in this case, has a tail, animal does not. But I do want you to notice something very, very, very important here. And this is line number 6, the super. Now, the super method will automatically execute a constructor on the original or the extended class. So whenever you have a constructor within your class and it has extended something, you always want to call super as the very first statement within your constructor. And this will call the constructor of the base class. So in this case, when I construct a new cat, it's going to first of all call super, which will call the constructor of my animal class, give me all the different variables for the properties, and then come back up and give me the tail equals true. So that's extremely important that when you're ever using the extends method to extend a base class, you want to always call super within the constructor. So this is how you can you can add properties to your class if that class is extended to other classes. Well, that's great for classes. What about methods? Well, you can add your own methods in here too. There is no speak method within animal, so therefore I have a speak method here within cat. And in this case, I can do whatever I want to, like, play an audio of a meow, but in this case, since everything is on the screen here, I'm just going to console log the text meow for speak. So whenever I execute the method speak on a cat, it will say meow. Can I execute the method speak on an animal? No, because there is no speak here on the animal. There isn't. It's just born. That's it. Now, you can redefine a method within your cat or within your super class. And to do that, you just merely redeclare it. I have now redeclared a method called born here. But something very important is that I can still always call what was originally inside animal by saying super dot and then the method itself. And this will automatically call the born method in animal, which, if I remember correctly, it sets alive equal to true. And then I can set the legs equal to 4. So if I just created my cat on its own, I would have a tail equals true with no legs, and the cat wouldn't be born. And the cat is not going to be born until I until I execute born. But when I execute born, it's going to first set the alive flag to true, because that's what animal does, and by using the super dot method, super dot born in this case, and then I'm going to set my own properties just like I have before. So in a nutshell, that's what you want. That's how you create a class that is extending another class. You can redefine the methods. You can call any of the information that is within the base class by using the super for the constructor or the super dot method for the form method, and you can add your own properties and you can add your own methods. So what's going to happen down here when we finally get to it? Well, when we finally get to it, make sure it's on the screen. When we finally get to it here, we're going to create the new cat. That's going to give us the 5 properties here at head, body, legs, arms, and alive. Plus, it'll give us the new property called tail, and then I'm going to let the cat speak by saying meow. Want to see how it works? Of course you do. Let's take a quick look. Let's flip over to our node, And let's type in node extends. Aha, and sure enough, there we are. Here are my 5 original properties that were defined inside animal, plus my new one that is exclusive just to cat. Now, why isn't legs set to 4? Like I said, for like when it wasn't born, because I haven't executed born yet. And of course, here's my out. Let's execute born. Let's see what happens. So let's go back over to our code. So before we console.log, let's do my cat. Oops. Got to type my cat.born. Now, alive should be true and legs should be 4. Alive is true because we're calling the super method, which calls the animal method born, and legs equal to 4 because that's what we used inside our born. So we've got that. And let's go over to back to node. Let's clear our screen. Let's take another look at it. Yeah, sure enough, alive is true and legs equals to 4. So that shows you how you can extend a class to create a superclass. It will allow you to use all of the properties and methods of that extended class and then add your own properties and methods to create a completely new class. Next, let's take a look at static properties. So what is a static property, and by definition also a static method? Well, a static property and a static method are properties and methods that are associated with the definition of the class, but not individual instances. Remember I said earlier that if you created a property, that property was within the constructor, it was a public property, and each property was created for each instance of that particular class. Same thing with the method. It's available for each instance of that class. Not so with static. Statics are associated with the definition itself and therefore are not created for each individual instances. So if you were to call if you were to access a property within a static property within a class, or if you were to access a static method within a class, you would have to access it based upon the class definition, because it's created one time with the definition and it is not created with each individual instance. Let's see how that syntax looks. To be able to define statics, all you have to do is put the word static in front. For instance, this particular one is a static property called types. Now, static properties are also normally used as enumerators and things like that. So what I have done here is I've given the general default for enumerators and capitalize the whole shooting match of the variable name. You can do whatever you want, whatever works best for your particular environment. This is just what I'm particularly used to. But the idea here is I now have a variable called types, and it's just a simple little dictionary variable, just little key value pairs of cat, dog, horse, cow, coyote, roadrunner, dolphin, whale, and lizard, but it's defined as static. And that means that this property is associated with the class definition of animal and not with each individual instance. Same thing with this method. The method is just simply a function that I've defined here by putting the word static at the very beginning. And so valid type is a method name that is now associated with the class definition, but not each individual instance. How do we know that? Well, how do we access it? Well, here's a perfect example here within the valid type. I want to be able to ensure that the type that I'm using for the animal that I'm creating is a valid type. To access a static method, I have to access it off of the definition of the class. Notice I'm not saying return this dot types. There is no such thing as this dot types, because types is a static variable or a static property, and a static method is associated with the class definition. So to access it, I have to physically say animal dot types. To access valid type, I'm going to say animal dot valid type. And you'll see that here within the constructor. This is the same constructor we've used before. Head, body, legs, arms, and alive. We've all seen that before, but I've got a little extra little thingy inside here, which accesses the valid type method of the animal. Again, I cannot access it using the word this, because static variables and methods are not associated with an instance. They're associated with the class definition. So I said animal.validType, and I passed a variable called type within the constructor that I'm only accepting these 9 particular types. Anything outside those types, I kick out and say it's invalid. And if it happens to be invalid, I'm just going to throw I'm just going to throw an exception and everybody's going to be wailing and gnashing teeth and be unhappy and all that. Otherwise, I just do the exact same thing I've done for everything else here. So let's take a look at some of the code that we're using. Let's make sure we get it up on the screen there. And the code itself, here I'm trying to create a new cat. And it should work fine because I'm passing the type of cat. And when the constructor calls the valid type static method, it's going to pass type into my types variable up here and check to see if cat is part of the variable. And if it is not undefined, which means it is there, then it returns, hey, true, valid type, or false, bad type. So my cat should work because my cat is there. And I'm just going to console.log my cat to show you that the types and the valid type are not part of there. I'm also going to try horse, so that should work. I'm also going to try roadrunner, that should work. And then I'm going to try dinosaur. And dinosaur should not work because dinosaur is not part of these types. You want to see how it works? Let's take a quick look. Let's go over to our code. Let's type in node static. And boom! Yeah, oh, we got some sort of big error, but let's take a quick look at the console.log. Remember, I console.log my cat. Cat is just like the animal like we had before, and it's got a head, got a body, got a leg, it's got an arm, got an alive. But notice no types. And that is again because static types and static methods are associated with the definition and are not created with each and every instance of the class that is created. So with my cat created, I've got my 5 properties there, but I do not have types. And I just wanted to show you that to make sure you understood that that was important. Now, how do we know it all works? Well, we know it all works because we got this really ugly error that has occurred here. And what was my error? You cannot have a type of dinosaur. And that just basically means that our particular constructor used the static type. Let's go back over to our code here real quick. It used the static method called valid type to check the static property called types against the type variable I typed in there. Well, I don't see dinosaur here, so it came back as undefined. And since undefined is a false value, this threw the error. So that's really all there is to statics. Statics are absolutely wonderful for things like enumerated values, like I've done here, or for anything that you don't necessarily need to have created with each and every single instance of your particular class. And enumerated values are a very good example of that. So again, statics are great for properties and methods that you don't need to have created on each and every single instance of your class. And that's basically all there is to static properties. And that's all there is to classes in JavaScript. I hope you enjoyed our video. Hope I didn't bore you to death. Please visit us at www.boringjavascript.com. Subscribe to our YouTube channel or find out everything we do at blog.thevirtuoid.com. Thanks again for watching, and we'll see you later.